So what this video is going to go over is what I call part two of the forces and charges worksheet. And again, what I'm going to explain is the table and what are the relationships that you are seeing between charge, distance, and force. So again, if it makes more sense to you to kind of draw lines here so that you could see that this is separate experiments, let's say, situation B, A, B, C, and D. And we have two charges, a positive and a negative. So again, this could be protons and electrons. This is going to build into what we're talking about with claim evidence and reasoning eventually. But this could also be a cation and an anion. So again, it's just a positive and a negative force. What positive and negative charges, how does it affect the force? Now, please realize here in this part two, the distance is changing, okay? So the charges are staying the same, but the distance is changing, and then the force is changing from that. So we're going to compare situations again. So I'm going to look at experiment A versus experiment B, and I will see that the charge is both +1 and -1, but I see that the distance goes up to 2 versus 1. And I see my force goes from 90 to 22.5. So what is changing between these two situations? My distance is increasing by a factor of 2. Okay, so again, I could do a multiply by 2 is fine, or you could say doubled, whatever makes sense to you in terms of the language that you like to use. What is kept constant is charge 1 and charge 2 are not changing. Okay, so what happened to the force? Okay, so we're looking at 90 to 22.5. So again, not bad idea to write out the actual numbers and see what factor you get. I get a factor of 4. I get a factor of 4, but it's going down by a factor of 4. So I'm not multiplying by 4, but I'm actually dividing by 4. So what's happening to force is, if I could write it correctly, is it is going down by a factor of 1/4. So I'm essentially taking the force, I take 90 and multiply it by 1/4. So I'm taking 90 and dividing it by 4. Well, what is that equivalent to? What is 1/4 coming from? I essentially doubled the distance. It went up by a factor of 2. So I essentially squared that. Whatever I did to distance is what I did, but it's an inverse relationship. It's an inverse relationship. So that's where that came from. So let's look at A and C. Okay, so let's look at A and C. Again, charge is staying the same. Distance is going up by a factor of 3, going up by a factor of 3. And then I'm looking at my force. Okay, so that's going from 90 to 10. So what has changed between these two situations? My distance is going up by a factor of 3, or again, you could say tripled. What is constant is charge 1, charge 2. And what happened to the force? So I'm taking 90 divided by 10, that's a factor of 9, okay? But it's going down, it's decreasing. So again, if this bothers you, then do 10 over 90 and you will see it's 1/9. So if that makes more sense in your head to kind of do those numbers, what did it become to what did it start with? You could then see the factor a little easier. So what happened was I took my force and I multiplied it by 1/9. Okay, well, what is 1/9? It is 1/3 squared. So again, the 3 comes into a play here. Okay, so I'm always squaring what I'm doing to distance, and I'm taking the inverse of it and multiplying it by it. Or you could say you're dividing by that number, whatever makes sense to you. So what is the pattern you notice? So as I increase distance, okay, force decreases. Okay, force decreases. So this is what we call an inverse relationship. Okay, so when one variable goes up and the other goes down, that's an inverse relationship. So the relationship is 1/distance, whatever I'm doing to distance squared. Okay, that's what I'm going to multiply that by. Okay, so we have a relationship statement that we could write here. So I'm going to pause it, and then you will see in a second the relationship statement. So here is the relationship statement I would put in there. The relationship between distance and force is an inverse squared. So I underline the important part of the relationship statement. Relationship between distance and force is an inverse squared. So again, I'm taking the inverse of the distance and I'm squaring it. That's what the language is telling you. If both charges are constant, if both charges are constant. So distance, think of two magnets, okay? Closer you could get two magnets, two bar magnets, the more force you're going to feel. If I start to increase that distance, you're not going to have as strong of a force between those magnets. That's going to be the easiest parallel that I can give you here. So again, we have a positive and a negative. So we kind of have two bar magnets, north and south. And so if I bring them closer together, you're going to have a much stronger force, harder for you to pull them apart than if they are way far apart. So what I'd like you to do now is to turn to the next page and see if you could fill out number 5, make predictions in the table below. So see if you could find what would the charge be for situation F, and then what would the forces be for G and H. And then after a second here, I'm going to pause the video. So you pause the video, you try it, and then you're going to see me explain it. Actually, I was on the wrong place. So you're going to go to number 10. On this next part, so part 3, and you're going to predict F, G, and H. So what would the forces be? Because here I am also changing charges and I'm also changing distance at the same time. So again, try to fill out number 10, sorry for the confusion, and see in a minute, I will, or excuse me, pause the video and then I will come back and explain it. So if you want a quick check, okay, and then I'm going to explain them, okay. For situation F, I was essentially doubling the charge for charge 2, and my distance is going up by a factor of 2, so my force goes down to 10. I will explain each one of these in a second. Then a G, nothing's happening to charge compared to E, but my distance is going down by a factor of 10, so it goes up to 2,000. And then H, I'm doubling both of my charges and I'm keeping distance the same. So that's why it should end up as 80. So let me explain each one of these to you, and it'll make a little bit more sense. So again, E to F, I am doubling charge number 2, okay? So what you should always do with these types of problems, if you are doing both charge and distance, is always do charge first, always do charge first. So I am doubling my force, so it goes up to 40, and then distance is going up by a factor of 2, so it's going to be 1 over 2 squared. So then it's going to go down by a factor of 4, so that's why it ends up as 10. So from E to G, the distance is going down by a factor of 10, so I'm multiplying by 1 over 10. So I take my 20 and I am doing an inverse of an inverse. So it's going to be 1 over 10 squared. So it's going to be 20 times 100. And then E to H, charge is going up by a factor of 2, charge going up by a factor of 2. So I multiply by 2 and then multiply also by 2.